All right, well, we've now moved forward to chapter 8, rational functions and relations. And we start off in chapter section 8-1, multiplying and dividing rational expressions. Now, I'm going to say to you that this chapter section can be a little bit of a bear. And I say that not because it's actually so hard. It's just that we're going to have to use a lot of our skills, and there's a number of pieces to everything we're going to do. And since there's so many pieces, it's easy to make a mistake here and there. And so you really have to be patient and persevere through this chapter section. But if you are, you can do it. Now, we start off here, we're going to simplify a rational expression. And we got two things we're asked to do. One, simplify the expression. And then second, state under what condition the expression is undefined. Now, since we're dealing with rational expressions, we got things in the denominator. We already know that we cannot divide by 0. And so anything that would cause us to divide by 0, or in this case where y would equal something, that would cause us to end up dividing by 0, then we're going to state what those conditions are. In other words, y cannot equal a given amount. So here we've got 4y times, in parentheses, y minus 3 times, in parentheses, y plus 4 over y times y squared minus y minus 6. Now in the numerator, the 4y is a monomial, the x minus 3 is a binomial, the y plus 4 is a binomial, and then we got a monomial in the denominator in the form of just y, and then we got a polynomial in the y squared minus y minus 6. And we got to get all this to the greatest common factor. So when I look at that expression in the denominator, y squared minus y minus 6, well then I know I've got to factor it in order to find this greatest common factor to help me simplify all this. So let's begin. I'm not going to do anything with the numerator in this case because I got monomials and binomials. So I got 4y times y minus 3 times y plus 4. And I'm going to attack the denominator by factoring this y squared minus y minus 6. So I got y, and I'm going to put in brackets here because I'm going to factor this. Y minus 3 times y plus 2. And that should be the factor. Remember, I'm looking for two numbers that are going to multiply to -6 and add to -1. If I need to, I can FOIL that back. Y times y is y squared. 2y, 3y, that's going to give me -y. -3 times 2 is -6, so I've factored it. Now that I have factored it, I can now begin to start simplifying it. And I'm going to work with monomials and binomials separately. So here I got 4y over y. Well, the y's are going to cancel. It's just going to leave me with 4. And the expressions y minus 3 appear in both the numerator and the denominator. And so those are going to cancel. And so to simplify this, I end up with 4 times x plus 4 over, it's y plus 4, excuse me, y plus 4 over y plus 2. Now that has simplified the expression. But now I've got to go to the second part. Now, under what conditions is the expression undefined? Well, I've got three factors in this denominator. I've got the y, I got the y plus 3, and I got the y plus 2. And I'm going to set each one of those factors to 0 to help me determine under what conditions the expression is undefined. Well, the first is just y equals 0. So then I can say that y cannot equal 0, because if y is 0 and you're multiplying 0 times y squared minus y minus 6, we're just going to get 0. So y cannot equal 0. Then I got y minus 3 equals 0. Y is equal to 3. So if y is equal to 3, that's going to cause this factor to be a 0, and therefore y cannot equal 3. And then we got y plus 2 equals 0, or y equals negative 2. Therefore, y cannot equal negative 2. Because again, if I plugged in negative 2 in this expression right here, if I plugged in negative 2 for y, I got negative 2 plus 2, that's 0. That makes the whole denominator 0. And that would cause it to be undefined. All right, let's go look at another one real quick. It's of similar nature. Let's see what we're going to do with it. All right, this time we got the same instructions. This time we got 2z times z plus 5 times z squared plus 2z minus 8. And then I've got z minus 1, z plus 5, z minus 2, all in the denominator. Now, I don't have any polynomials in the in the denominator, but I do in the numerator. And so I want to go ahead and factor that polynomial, z squared plus 2z minus 8, so that I can simplify. And so I'm just going to start by 2z times z plus 5. And you can probably already see I'm going to be able to cancel out the z plus 5s. And let's see, factoring this, I would have z plus 4 times z minus 2. Looking for two numbers that are going to multiply to negative 8. So 4 times negative 2 is going to be negative 8. And when added together is going to give me 2 for that middle term. 4 minus 2 is 2. And that's going to be over z minus 1 times z plus 5. And I'm getting ahead of myself. Z plus 5 times z minus 2. So let's go ahead and start simplifying this thing. Well, I got a z plus 5 in the numerator and a z plus 5 in the denominator, so that's going to cancel. And I got a z minus 2 in the numerator and a z minus 2 in the denominator, and so that's going to cancel. And so this is going to then simplify to, let's see if I got enough room down here in the bottom to write this, 2z times z plus 4 over z minus 1. So that's simplified it. Now let's take to the next step, and under what conditions is the expression undefined. So I'm going to set each one of those three factors, z minus 1, z plus 5, z minus 2, those are all factors. I'm going to set each one of them equal to 0, solve it, and that tells me what z cannot equal. Because if it does equal it, then that's going to throw my entire denominator into a 0. Any one of, it's going to be 3 of them, any one of those 3. So let's start. Z minus 1 equals 0. Z equals 1. Well, z cannot equal 1. Let's do the next one. Z plus 5 equals 0. Z is equal to negative 5. And that means that z cannot equal negative 5. Because if it did, the denominator is going to 0 and the expression is going to be undefined. And let's finish it. Z minus 2 equals 0. Z equals 2. So therefore, z cannot equal 2. All right, we've done it. It's not too bad. We're going to see some that get really kind of squirrely a little bit later on. But hey, that's what makes it fun.